Hello everyone, my name is Raghunath and I am from CSM third year. Today I will be explaining some fundamental topics related to large language models including what are LLMs, APIs for LLMs, retrieval augmented generation, base models, what and how can we use LLMs and how to get and create LLMs for our work. Firstly, what are LLMs? LLM stands for large language models which are trained on large textual data and used to answer queries and domain-based questions. We can integrate them in various platforms like web, Android, and which help us in streamlining the services. Here is a quick example of LG website which uses LLMs for Q&A, which is an example of domain-based LLMs. LLMs can be huge in size, hence we need high specifications to run them in our system. So to achieve this, we can access model to API services like platforms like Grok and Gemini provide free tier services, and we can level up whenever it is required. Grok provides various models including Llama, Mistral, OpenAI, Whisper for both text and audio processing. If we have enough processing power, then we can directly run them on our local server by downloading them, using them from Hugging Face, and using inference services like Unsloth. We can get the models locally with the help of applications like Olama and Hugging Face, and we can run them without internet. So, in this process, we will download the embeddings and weights of that particular model and perform chat completion with the help of them. Most of the LLMs are designed in such a way that they solve queries related to generic information, but some of the fields such as healthcare and other and education fields, general purpose LLMs cannot fulfill the task and requirement. So to fill this gap, we can use two techniques. One of them is fine tuning, and second is prompt engineering. When we are dealing with the tasks that have frequent data changes, we can use prompting techniques such as RAG, which stands for Retrieval Augmented Generation, in which we load the model with our data. It contains three phases: loading, splitting, embedding, and storing. Whenever we query LLMs, initially it retrieves the most relevant data from the RAG that we have given to them, and it is efficient and accurate. But when if the latency completely depends upon the size of the dataset and complexity of the query. Now, when the data changes are very rare, then we can go with fine tuning, in which we will be updating the weights of some layers of neurons so that it generates the responses according to our requirements. For this, we will unfreeze the weights of last few layers of the model and then train the dataset. In this way, we can use its command knowledge, its existing knowledge, and answer the user queries according to our requirement. All LLMs that we have seen until now can only perform text generation and tasks and cannot automate anything further. Hence, for the task like automation, we can use the knowledge of LLMs to perform some of these tasks like data analysis and database querying and other tasks. This workflow is known as agentic workflow. Some of the existing libraries such as LangChain offer some of these functionalities inbuilt, and it is an active research area. Some of the well-known agentic workflows are querying through a database, automation, and running integrated script generation.